Well, I've had the boat out in the salt water, and now I'm fishing freshwater, and gave a try to the washdown pump in the morning, and it was working. In the afternoon, it was not. So now I got to do some troubleshooting. Okay, we're troubleshooting some electrical today. Kind of foul weather, so I can't go fishing, so it's a good time to do this. Got power to this area, the live well. You can hear that? It's going. But the washdown wasn't working. It worked in the morning, but it wouldn't work in the afternoon. So there's something going on there. I'm going to troubleshoot and see what's happening. Okay, so the hose has got a little quick release on it here. So that pulls out. Clever. Get that out of the way. Now we just got to remove these 4 screws. We can pull it out so we can see it a little easier out here than we can in behind where it's a little bit congested. And we get it out and we can see there is a lot of corrosion. Salt water, not a friend of electrical. And so we can pull these connectors off, see what the orientation is and the colors, where they go, and see if we've got some power there. Okay, so we got those off. You can see a little bit of that green is not a good sign. This position there, the top is obviously black ground, and then we got power in, and then we have power out to the pump. And this has a ground, the black wire, the negative is so that it has a little light, a little telltale light to tell you that this is on, in case you can't hear it. And so that's its purpose. So there'd be power coming to it. So the one thing we want to check now is to see if we have, when we flip the switch, do we have continuity between the power in and the power out on the positive side. Okay, we've got our little multimeter here. We're going to switch it to ohms, little upside down horseshoe thing. That'll give us milliohms mode. There we go. Ohms. So this is a little horseshoe up there. Then when we it's handy, it's a little tone. Tell you if you got continuity. Okay, now with this shot, we're going to try top guy, the bottom guy. Got nothing. Flip a switch. Got nothing. Two together, should be making a contact. Got nothing. It's open. Got nothing. So looks like we got a bad switch. Okay, so now while we're here and have everything apart, we can go to our voltage, DC voltage on here, and we can see if we're getting voltage across our leads coming in. Okay, get power in there. Oops. Nice to have clamps here. But we don't. So here, that. Like that there. We're getting 12 volts. Okay, so that is telling us that we have good wiring. If not a little bit mucked up from the salt. But we're getting 13 volts. Wonderful. Okay, so here's some stuff that we're going to need. We're going to try to clean all this electrical stuff up. This stuff is electrical contact cleaner, a little aerosol spray, which works very well. Turn the power off. These can be flammable, and so you don't want to be in a position where you'd start a spark and get a torch going. This is silicone paste dielectric grease, waterproof dielectric grease. Now, this stuff can be overused, and we'll show you how to apply that. The concept is that this will keep the moisture and salt contact with these pieces of the electrical components as they come together. You don't want to coat it completely because you need to make contact, but you do want to try to seal off the moisture and air and whatnot from getting on those. So it's kind of critical on how you place them. This is another little rocker switch. This is a lighted switch that seems to be working pretty well. Marine grade. They say it's sealed. They'll fail. It's just a cheap switch that's going to fail. This is why we're doing this, and it will do it again and again. Get several of these because the inside contacts just can't handle, especially a salt environment. Over time, you'll be redoing it. I don't think there's any easy way around it. These are little dental flossers, right? And they come in different sizes. This is one company that makes them that's pretty good. And they have a little test, their sample kit that if you have issues with flossing, this is very helpful as well. But they're different sizes, as you can see. So when you're cleaning out these components, this helps you get it agitated in there. After you spray the cleaner in there, you can try to brush them up and get them as clean as possible before you do the reconnection. So with the dielectric grease, what you want to do is you put it on the male tabs on here, but not at the top, at the near the bottom, where it'll make contact, and then it'll seal off into the female receiver and seal out as much moisture as you can. Try to keep these contacts making good electrical connectivity. Okay, just for our own curiosity, we're going to go ahead and see if indeed the new switch has conductivity through it. Yay. So that is working. Not bad to test them before you put them in. We all know where they're made, and we know that sometimes they work, sometimes they don't. Okay, power is off to this. Could wear gloves. Wouldn't be a bad idea. You can see all the corrosion in there. Pretty nasty. Okay, so that's step one. Then you come in and Hit it with Mr. Flosser. Try to clean it out as best you can. Get all the points of contact. Doesn't hurt to rinse and repeat. And that stuff. Okay. Okay. Get as much of this corrosion off as we can. And we will give it a shot. Okay, so these switches, they're just tilled in. They've got little tabs that stick into the opening. So it's pretty simple. So to get the old one out, you just compress it and push. Oh, there's one side, there's the other. Out she comes. Easy peasy. So I cut open the old switch to see how it had failed. Okay, so it's just a simple contact. I think that contact in there, that's what corroded. And so it wasn't making good transfer of power. That's how the switch failed. Connections are pretty bulletproof, so that had to be the weak point. It's the points. No way of getting to maintaining them. So you got to replace the switch. Luckily, they're not expensive. Right side up, negative up. Oh, do not tell me they're a different size. Slightly different. Uh-oh. Looks like we have a slightly different size than what we got in here. Wouldn't that be the thing? Okay, got to make the hole bigger. Okay, we got to make this a little bit wider. I am choosing the multi-tool. Yeehaw. Fine blade on it. See that? Just because I'm used to it and I like it. You could probably do it with a drill and a drill bit and just widen it out a little bit. Doesn't need much, but this will work. Cut the side of it and then we'll get it to fit. finish the corners off with a little drill bit. Easy peasy. Okay, quick test to fit. Gonna work. I can put it together. Test it first. Okay, so we know from our photos initially that the top is the ground, the black wire, and then the power goes in the center just from observing it before we took it all apart, and then the pump lead to the pump goes at the bottom. That's important because you want that little light to work whether the pump's going or not. So we're going to take the dielectric grease. We'll use a little bit of applicator. They make smaller tubes of this stuff. That's a lot easier to apply. But this is kind of the bulk I got from Costco or something. So I'm going to get it at the bottom on the male adapters. Don't be shy. Once you've got it down low. Can't hurt anything there. You just, if it covers the whole spline on there, or the whole blade going in, then you have potential if it just cuts off the contact, because it does not. It's not a conductor. Material is not a conductor. It's just meant to seal off the air. So you still have to have metal to metal contact. Okie dokie. So that being said, put the power lead in the middle. Pump on the bottom. And see, there's good contact, good grease, good having good grease, and it doesn't hurt. You can actually grease up the rest of the stuff too if you want. Again, it's not going to hurt anything. There we go. Pretty good coating. Okay, now let's test it and see if it works. Okay, power's back on. Oops. Lights on. So we got power to it. Not hearing the pump going though. That could be a problem. So it turns out that this washdown pump has a pressure limiting switch that won't let it run unless there's some water up against the pump diaphragm. So that was the issue. I had to get some water applied to the system so that it had something to pump with. Okay, I got a 3/4 inch male, or excuse me, 3/4 inch female pipe thread, and then a hose bib, and then a double hose bib connector. Hooked a hose up to it so that I've got some water pressure against this thing. Filled up the hose and ran it just enough above the pump on the boat that it give it a little bit of pressure. Let's hit the switch. Yep. Well, So, good lesson to start with the easiest and least expensive link in the chain. And that turned out to be the case. These switches are not expensive, but they are prone to failure. So that worked out well. We got the pump back up and running in short order, and it wasn't too expensive to fix. Take care of the electrical wires, and then hopefully with that dielectric grease, this will last for a long time. Hope you liked the video. Please hit the like and subscribe, and it'll keep me doing these. Thank you so much for watching.